Incoming transmission.
Well, Commander, I have learned it is never a good idea to play around with the forces of nature. But with this evil Romanov running loose again, we have no choice. This weather control device provides very advanced manipulation of the weather patterns. These are God's toys, Commander. Use them wisely.
Humans have worked on controlling the weather for well over 100 years, and in 1946 the first artificially provoked snowfall took place near Mount Greylock in western Massachusetts. So we have figured out how to make it rain and how to make it snow. But can we create lightning storms? Let's start by talking about how to make it rain. It is done through a process called cloud seeding. The basic principle is that you release chemicals into the air that causes water vapor to condensate, forming rain droplets, which in turn forms rain clouds. These chemicals are usually some kind of salt, such as silver iodide or potassium iodide. They are most commonly released from a plane, but could also be released from the ground. Now, if we look at the weather control device, it does not exactly look like you would expect a cloud seeding station to look, but since 2021, a new method of provoking rain has been implemented in the United Arab Emirates, involving electric charge. They send drones into the clouds with the purpose of electrically charging rain droplets. The idea is that charged rain droplets will attract each other, forming bigger droplets, which has a higher probability of falling. Now this seems to be a bit more in line with the electrical discharges we see when the weather control device is active, and it does seem to have the capacity to deliver electric charge to the clouds straight from the ground, without the need for drones. Now the question is, does any of these methods increase the chance of lightning? Well, whether or not cloud seeding can actually increase the risk for thunderstorms seems to be a much debated question. An article from 1959 states that the University of Arizona observed an increase in lightning bolts from clouds seeded with silver iodide by a factor of 9 compared to unseeded clouds. A scientific article released in 1967 then states that the data collected regarding the silver iodide seeded clouds over Arizona between 1958 and 1962 does not allow for the conclusion that cloud seeding influences the amount of cloud-to-ground lightning. Regardless of whether or not cloud seeding does actually have an effect on lightning, it certainly does not seem to be a consistent or reliable way to create it. It should also be said that cloud seeding can only be done successfully in certain weather conditions. If there is not enough moisture in the air to begin with, cloud seeding will have no effect. So, we can probably rule out conventional cloud seeding as a method of creating thunderstorms. Now, before we continue, let's figure out how lightning storms are created in nature. The sun heats up the ground, which in turn heats up humid air above it. The humid air ascends, and once it reaches a certain level in the atmosphere, clouds are formed. As the air is heated further, the cloud expands vertically. This cloud, reaching high up into the atmosphere, now contains water particles in different states, such as small ice crystals, hail, and water droplets. The light particles, such as the small ice crystals, ascend to the top, while the heavier particles descend. As these particles collide with each other, they exchange charge carriers, causing the bottom of the cloud to be negatively charged and the top of the cloud to be positively charged. Once the voltage difference between the cloud and the ground becomes high enough, an electric arc will form in between, which we perceive as a lightning strike. So, can this phenomenon be replicated? Well, nature actually has its own weather control device. This is a volcano, and what we're seeing above it is volcanic lightning. Volcanic lightning occurs during an eruption as the result of several different charging mechanisms. For example, ashes and dust particles rubbing together in the smoke plume producing static electricity, or rock particles becoming charged in the process of breaking apart. But the mechanism we are going to take a closer look at is ice charging. This is more or less the same phenomenon as for regular thunderstorms, but instead of the sun heating humid air that ascends to form clouds, water from surrounding sources such as glaciers and lakes is evaporated by the heat from the magma. So, I think that the weather control device produces artificial volcanic lightning. And judging by the electric arcing, it uses high voltage to produce large quantities of water vapor. I think that the 4 spheres around the center are high-voltage electrode boilers, producing steam that feeds into the large high-pressure steam tank in the middle, to be released when the weather control device is activated. Electrode boilers passes electricity through water to create steam. The water acts as a resistor between the electrodes, so when voltage is applied between the electrodes, current will flow through the water, heating it up. When it gets hot enough, it evaporates and turns into steam. So, why use high-voltage electrode boilers instead of more conventional heating methods such as fossil fuel boilers? Well, aside from being more compact and not generating any emissions during operation, electrode boilers are extremely efficient at converting energy to steam in comparison. So, when the weather control device is activated, a large amount of steam is released into the atmosphere, similar to what can occur during a volcanic eruption, creating the right conditions for a thunderstorm. So, now we have a thunderstorm. Now the question is, how do we make sure that the lightning strikes our enemies and not ourselves? Could it be possible to initiate a lightning barrage with such precision? Well, it probably is. One method of provoking lightning is by shooting a rocket towards the thunderstorm, carrying a thin conductive wire between itself and the ground, thus providing a low-resistance path between the cloud and the ground. Electricity chooses the path of least resistance, so it is highly likely that this will provoke a lightning strike traveling along the length of the wire. Now, we do not have the opportunity to fire a bunch of small rockets from the enemy base. We will need a long-range approach. And it turns out that we can do something very similar with lasers. With an ultra-high-intensity laser beam burst, it is possible to ionize air, essentially creating a trail of plasma along the laser beam. This plasma is conductive and will act similarly to the wire along the rocket. This has been demonstrated in Switzerland in 2021, where a laser beam was used to guide lightning to a telecommunication tower equipped with a lightning rod. I'm thinking that it should be possible to do this from a distance. If you have multiple lasers that is not strong enough to ionize the air on their own, but where they intersect, the intensity will be high enough to create a trail of plasma. This would mean that you would be able to have the lasers intersect right above your enemy, thus aiming a lightning strike with laser precision.